Alright guys, ladies, gentlemen, peeps, welcome back. 3.2. This is an intro to functions. The first thing that we want to know is what a relation is. A relation is simply just a set of ordered pairs. So it could be written this way, it could be written this way, lots of different ways that we could write a relation. It just means that there's some first elements, and those correspond with some second elements. So they have some kind of a relation or a relationship. Okay, so in this case, A corresponds to 3, and C corresponds to 3, and E corresponds to 1. So all the first sets are the first elements, and the second set is the second elements. Okay, so this is what we refer to then as domain and range. Domain is all of the first components of the ordered pairs. Okay, so we say first components, but most of the time these are X's, but they could be T's, S's, D's, A's, B's, whatever. Okay, but it's all the first components. And the range is all the second components of the ordered pairs. So that's all the possible Y values is the way that we think of that most of the time. So to define a function is when each first component corresponds with exactly one second component. Okay, so in other words, your X value or your first component cannot repeat itself. So if I were looking, we have a couple examples on your sheet that show you, like there's this example, and then there's an example of ordered pairs and an example of a line, and those just demonstrate a relation. Okay, and we can say the domain is all of the first values. So on that first ordered pair that has the values of -3, -1, ordered pair 1, 1, ordered pair 2, 3, ordered pair 3, -2, the domain would be the -3, 1, 2, and 3. The range would be the -1, 1, 3, and -2, and so on. So with the line, it's going to be all possible values, but there's going to be, again, set values for X and set values for Y. But if you're talking about domain and range and a line goes on forever, eventually the line is going to reach from -infinity on the X to -infinity, or to +infinity on the X, and it's also going to go to from -infinity on Y to +infinity on Y. Okay, so we want to determine the domain and range of each of these relations that I wrote here. So with these relations, again, the domain is just all the possible X values. So we would just say the domain is 4, and when it repeats, we don't write it again. So we just write 4 and 5 here would be our domain. So this is our domain. Our range would be equal to 1, -3, -2, and 6. So the only possible X values, or the only possible first elements are 4 and 5. And with the range, we have all of these. So this here would not be a function because you can see that the X values repeat themselves here and here. And so this would not be a function. On the second example here, the domain, all the possible X values, is just going to be 3. Every single one of these ordered pairs is 3. It's 4, 3, 3, 3, 2, 3. Sorry, it's 3, 4, 3, 3, 3, 2, 3, 1, etc. So all of the domains are all just 3. Okay, but the range here on this graph right here would be from -4, -3, -2, -1, 0, 1, 2, 3, and 4. So that is the range. It's all of the Y values of these ordered pairs, or the range. And again, this would not be a function because you can see that the x repeats itself on all of these spots. So you would have the ordered pair 3, 4, and the ordered pair 3, 3, and the ordered pair 3, 2, and this x value repeats itself over and over again. So that would not be a function as well. Okay, so for this last relation here, the domain would be each of these inputs: accounting, computer programming, engineering, social work, paralegal, which I've abbreviated, and our outputs will be all of these numbers, 51, except for 50 is not in the range because you can see that there's no relation here. None of the arrows point to this 55, so it is not part of the range. Okay, so these values are my range and these values are my domain. I also want to point out here that there is no 2 in this range. And you can see that there's no 2 in the second values. Okay, so that is determining domain and range. So again, what is a function? Well, a function, we kind of went over with these. There's a whole nother set there for you, but a function, the x values can't repeat themselves. All right, so determine whether the following relations are also functions. For A, we have the ordered pairs of -2, 5, 2, 7, -3, 5, and 9, 9. So as I'm looking at this, there is no x value that repeats. So this is indeed a function. Okay. Well, what about the B example? The B example has ordered pairs of 1, 5. This point right here, 1, 5. It has the point 0, 3. It has the point 0, -2. And it also has the point -3, 2. So question is this a function? Well, because as you can see, these x values here repeat themselves, then this is not a function. Okay, not a function. And for C, okay, so the input for C is going to be people in a certain city. So this could be like John, Bob, Lynn, etc. The correspondence is going to be their age. So if we had a bunch of ages here, you know, if we had like 5 and 11 and 17 and 85 and whatever, it's possible John can only be one of these ages. John can't be more than one of these ages, but it's possible that Bob could also be 5 and that Lynn could also be 5. Okay, so with the correspondence being each person's age, is this a function? Well, the question is, do people in a certain city, do these repeat? Well, while their names might repeat, the person themselves, they're all individuals. No individual can be more than one age. So we're not talking about their names, we're talking about the person themselves. So because no individual can be more than one age, then this is a function. Okay, because none of these values can correspond with 2 different ages, so this would be a function. Okay, so those are some examples that you have there on your guided notes. Finding the domain and the range of each relation. So this is what we're going to go into now. These are graphical representations. Another important way to tell if something is a function is if it can pass the vertical line test. The vertical line test says that if there's anywhere on the graph that you could draw a vertical line and it would pass through 2 points, 2 or more points, then it's not a function. Okay, so if it passes through 2 or more points, then it's not a function. Okay, so if I look at the graph A that we have here, looks like so this graph is going to look like this. And the question here is this a function? Well, if I took a vertical line and ran it through this graph, never at any point would there be 2 points on the graph touching. 2 points on that line touching. So this is indeed a function. Okay, and these points, we'll label them real quick. You've got them there on your guided notes. So, question here is, what is the domain and what is the range? Well, the domain is all the possible x values. So the domain is going to be equal to -3. See, it's going to include -3 because the value -3 is part of this. So if I were to go from left to right and say, where does this start? Well, it starts at -3 and it includes -3 and it keeps going until 5 and it includes -5. So this would be my domain. Okay, and my range, I'm going to go up to down. So nothing here, no graph here, no graph here. I get to right here and I'm at -2. That includes the value of -2, and I'm going to continue to go up the graph until I get to the highest point, which happens to be the point 4, and that is also included. So this function is a function, has a domain from -3 to 5, and both of those values are included in there. Okay, if we look at example B on your sheet, it looks like we'll see how easily I can recreate this. So it looks like this, and where this is -4, this is 4, this is 2, and this is -2. So these points here that they're going through. Okay, so this graph does not pass the vertical line test. As you can see right here, I would have 2 points like there and there that would be touching this line. So this does not pass the vertical line test, so this is not a function. Okay, and if it is not a function, then does it have a domain and a range is the question here. So not a function, what is the domain and the range? Well, are we going to have one? Why or why not? Well, there's still possible x values and still possible y values. So yes, we do have a domain and a range here. And the domain is going to be -4, and it includes it in this point right here. This point would be 0, -4. And we have, it goes all the way to 4. So there's no point on this graph outside of -4 and 4 for my x values. For my range, there's no point outside of this graph from -2 to 2. Okay, so that is our domain and range for that one. We've also got 2 more. C is a parabola that looks something like this and touches here at the origin. Okay, so vertical line test. If I were to run a line across here, there's no point that would touch that line twice. So this is indeed a function. Okay, and because these have arrows and not specific dots, this is going to continue to go on forever. So my domain is going to be negative infinity to positive infinity. It could be any possible x value because it's just going to continue to spread. Okay, the range here though, I have no value below 0, but I do have the value of 0. 0 is included. But this is going to continue to go all the way to positive infinity. It's just going to go up, 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 up. So this is a function, and it does have, here are the domain and the range. Okay, for D, we've got a horizontal, sorry, not a horizontal line, but a line that's going to pass through. And it looks like this. Okay, so again, this line is going to go on forever. Vertical line test, though, says if I run this across here, there's no point that's going to touch it twice, so this is a function. And we are going to say that the domain then, this line goes on forever in the x direction. So this domain is again going to be negative infinity to positive infinity. And the range is also going to go on forever. So it's going to be from negative infinity to positive infinity. So hopefully that gives you a good idea of what domain and range are. The last portion here is that we're going to talk about is function notation. Function notation is just another way to say, so if I say that y is equal to 2x plus 5, and then I could plug in values for x all day. So we plug in -1, and when we do that, we get -2 plus 5 is 3. So we plug this in for x. So we plug in for x, and this spits out y. This means that y is a function of x. Okay, so the way that we write that, instead of using this variable y for function notation, it'll say the function of x, or the f of x, or it could say the g of x, or the h of x, or anything else, any other letter or variable. Okay, so we would just write this, writing it as a function. We could say, well, if y is equal to this, then y is a function of x, and it could be written in this function notation. Okay, so all this means is that when you plug in a certain value for x, that it will give you y. All right, so still looking at this, if we have the function, if we were given the function 4x plus 5, and the function g of x is 3x squared minus x plus 2. And we want to find the g of 0. Well, first I'm going to find the function that's represented by g. And what this means is everywhere I see x, okay, plug in 0. So this means plug in 0 for x. That's what this means, the way this is written. Okay, just making sure we're still recording. So to find the g of 0, everywhere I see x, I'm going to put 0. And then I'm going to work the problem in order of operations. So I'm going to say 0 squared is 0 times 0 is 0 minus 0 is still 0 plus 2. So the g of 0 is equal to 2. That is the value of the g of 0. The next one here is the f of 2. So I'm plugging this into the function here, and what this means is I'm going to plug in, okay, again this 2 right here means substitute 2 everywhere you see x, or plug in 2 for x into that function. So I'm going to plug in 2 and say, what is this value? Well, 8 plus 5 is 13. So the f of 2 is 14, or sorry, is 13. Okay, so I'm going to go ahead and pause the video for just a minute while you find the g of -5 and the f of -1. Okay, so go ahead and pause that and find those. All right, now we're back. If I plug in -5 in the function, the g of x, everywhere that I see x, and follow the order of operations, I'm going to get a -5 squared is 25. 25 times 3 is 75. This minus a negative is going to be add 5, which is going to give me 80, plus the 2 is going to give me 82. So this g of -5, the value of it is 82. This is just like evaluate, which means plug in and simplify using the order of operations. Okay, so that is my g of -5. My f of -1 says that I'm going to plug in -1 where I see x into my function f of x. Well, -4 plus 5 is going to give me 1. So my f of -1 is equal to 1. And here my g of -5 is equal to 82. All right, so that is how a function works. If you were given certain graphs and you were asked to find a value by inspecting the graph. Okay, so for instance, if we had the graph so, and this is the point 4, 2 right here. Okay, this is going to keep going though, but this is our point here, and this is the point -4, 2. Okay, and this is also going to keep going. So if I said, looking at this, then the question here is, what is the f of 4? Well, when x is 4, y is 2. When x is 4, y is 2. That is this point right here. This is my x value and this is my y value. So by visually looking, we can see that this is the f of 4. Okay, what about b? Well, the f of -2. Let's find the f of -2. Well, when x is -2, it appears that y is 1. Okay, so visually looking at the graph, I'm going to go where the x value is -2 and say, oh, well, y is 1. And again, y is the same thing as the f of x. Okay, let's do c. What is the... Got to draw my other graph here. The g of 5, and d, what is the g of 0? So this is my f of x here, the f of x equation, and here is my g of x equation, or graph, excuse me. So it looks something like this. All right, so looking at the graph, I want to find the g of 5. If I go to where the g is 5, it appears like, so if this keeps going and I were to draw where the f of 5 is, Okay, it appears like the f of 5 is at 4. Okay, the f of 0 is at 0 because the value here, so this is the ordered pair 5, 4, and this is the ordered pair 0, 0. All right, so it appears to be 0. I'm not going to worry about those last two. So this is the end of this section here. All right.